We start our day with a glass of water every morning. We take a bath, quench our thirst, water the plants. But have you ever wondered how old this glass of water you are drinking is? You might think it rained a few days ago or was extracted from the ground. But from the perspective of science, every atom or molecule of this water in your glass is older than our sun or the earth. Even the history of this water is hidden in the Great Explosion, or Big Bang, of the creation of the universe. Today, in the first part of our 25-minute documentary, we will know the story of water's cosmic journey, how a blue planet was created from a ball of fire, and how water came from the depths of space and brought life to our world. To know the history of water, we have to go back about 13.8 billion years ago. At that time, there was no time, no space, only a point of infinite density. Then, the big explosion happened, the Big Bang. In the first few seconds of the explosion, the universe was extremely hot. But within a few minutes, when the temperature decreased slightly, the first basic substance of the universe, hydrogen, was formed. We all know the symbol for water, H2O. That is, the main component of water is hydrogen. The basis for all the water on Earth today was formed in the first 3 minutes of that Big Bang. About 75% of the total mass of the universe is hydrogen. This is the oldest and simplest atom in the universe, but it is not possible to make water with hydrogen alone. Water requires another very important element, oxygen. And the universe had to wait for billions of years for this oxygen. It consisted only of hydrogen and helium. There was no oxygen. So where did oxygen come from? To create oxygen, extreme heat and pressure were required, which is only possible inside stars. When the first stars in the universe were born, the process of nuclear fusion began in their centers. Hydrogen molecules collided with each other to create helium. When the star reached the end of its life, helium fusion formed carbon, and oxygen was formed soon after. Simply put, the oxygen we breathe today and the oxygen mixed in water were created during the death of some massive star. When those stars were destroyed by supernova explosions, the oxygen inside them was dispersed into space. In this way, the universe obtained the water element in its entirety for the first time in billions of years of its history. To contact with each other in the vast clouds of dust and gas in space, interstellar clouds, water molecules began to form. However, these clouds in space were extremely cold. Scientists have seen through long studies that a thin layer of ice accumulates on these dust particles in space. These dust particles were the cosmic chemistries. Here, oxygen and hydrogen combine to form H2O. That means billions of years before the creation of the Earth, water existed as ice on dust particles floating in the deep darkness of space. This water later became part of various planets and star systems. 4.5 billion years ago, when our solar system was forming, a huge cloud of dust was orbiting the sun. This is called the protoplanetary disk. The region near the sun was extremely hot. At this heat, no water molecules could exist in liquid or ice form. They would evaporate. The temperature drops significantly. This boundary is called the snow line. Outside this line, water was able to freeze in the form of ice. That is why we see the outer planets of the solar system, Jupiter, Saturn, Uranus, and Neptune, filled with a lot of ice and gas. But the inner planets, Mercury, Venus, Earth, Mars, were rocky and dry. The arrival of water on Earth, comets or asteroids? It was once thought that since comets are mainly made of ice and dust, billions of comets may have crashed into the Earth and created the ocean. But later, when scientists examined the chemical composition of comet water, it was found that comet water has very little in common with Earth's water. The amount of deuterium, heavy hydrogen, in comet water is much higher. Comets or asteroids? It was once thought that since comets are mainly made of ice and dust, billions of comets may have crashed into the Earth and created the ocean. But later, when scientists examined the chemical composition of comet water, it was found that comet water has very little in common with Earth's water. The amount of deuterium, or heavy hydrogen, in comet water is much higher. Second theory, asteroids. Currently, the most accepted theory is that it was a type of asteroid called carbonaceous chondrites. These asteroids, which came from outside the snow line of the solar system, had a large amount of water mixed in as minerals. When these asteroids started hitting the Earth continuously, about 20 to 100 million years after the formation of the Earth, which is called the Late Heavy Bombardment, they brought with them precious water. When scientists tested the chemical signature or isotope of the water on these asteroids, they found it to be exactly the same as the water in Earth's oceans. This means that the water you drink today likely came to Earth from space on the back of an asteroid billions of years ago. Outside? No. Some water was also stored in the form of minerals in the deepest part of the Earth's mantle. When the Earth gradually began to cool, that water came into the atmosphere in the form of water vapor through the eruption of huge volcanoes. Over thousands of years, that water vapor condensed and began the longest rainfall in the history of the Earth. That rain that lasted for billions of years formed our vast oceans today. Scientists call it juvenile water, or the Earth's own innate water. Why is water the strangest and most powerful substance in the universe? The symbol for water is H2O. 2 hydrogen and 1 oxygen atoms are connected in such a way that it looks a lot like Mickey Mouse. The water molecule has a positive charge on one side and a negative charge on the other. Because of this property, water is called the universal solvent. It can dissolve almost everything in itself. Because of this quality of water, our blood can carry nutrients and wash away toxins within cells in such a way that it is difficult to separate them. That is why water remains liquid at normal temperatures. If this bonding did not exist, the Earth would be a dry desert like Mars. Density and ice. Usually, any liquid becomes heavier when it freezes. But in the case of water, it is the opposite. When it freezes, water becomes lighter and floats. If this did not happen, ice would start accumulating from the bottom of rivers or seas in winter, and all underwater organisms would die. Water protects life through this strange religion. There is a lot of water in the universe, but why is there no life on all planets? Because the Earth is located at just the right distance, which is called the Goldilocks zone. The temperature here is such that water does not evaporate, nor does it remain frozen all year round. Liquid water is the main condition for life. The Earth has been able to retain this water through its strong magnetic field and atmosphere, which Mars or Venus could not. From today's first episode, we learned that water is not just a mixture of hydrogen and oxygen. It is a cosmic legacy. Starting from the Big Bang, the death of stars, the collision of asteroids, and billions of years of rain, all this has created that little bit of water in your glass. The universe has gifted us this blue blood. You see a human being, a body of flesh and blood. But in the eyes of science, you are actually a walking bag of water. About 60 to 70% of our body weight is water. That is, if you weigh 70 kilograms, about 45 kilograms of it is water. The pulse of life, our thinking, our movement, all of these things are based on the magical molecular power of water. It is not impossible to imagine life without water, but it is scientifically impossible because every tiny chemical reaction of life occurs in the presence of water. Every living being, animal or plant, is made up of billions of cells. The thick liquid substance inside these cells, which we call protoplasm or cytoplasm, is mostly water.
Water not only maintains the shape of the cell, but also acts as a medium in which all the organelles of the cell, such as mitochondria or ribosomes, remain active. It is because of this presence of water that the proteins inside the cell get their correct structure. Without water, our DNA would not be able to maintain its twisted structure. Proteins would stop working, and all life processes would grind to a halt in an instant. Water transports nutrients into cells and removes waste products. The most visible form of water in our body is the blood. About 90% of blood plasma is water. This water is actually our body's main transportation system. The food we eat is digested into glucose, amino acids, and mineral salts,
and enter the bloodstream, reaching every cell in the body. Similarly, water carries carbon dioxide and other toxic waste released from cells to the lungs and kidneys. If water were to lose its fluidity today, our body would become useless within minutes due to lack of nutrients and the pressure of toxic waste. You would be surprised to know that the most important organ in our body, the brain, is about 75 to 85% water. The brain is a highly sensitive organ that floats in a layer of water called cerebrospinal fluid. This layer of fluid protects the brain from external injuries, just like a cushion or pillow. But water's work doesn't end there. When the neurons in the brain exchange signals with each other, they need ions like sodium, potassium, and calcium. These ions flow through water. So whenever our body is slightly dehydrated, our attention decreases, headaches start, and we feel tired. Due to lack of water, the brain actually starts to shrink, which slows down our ability to think.
Possible with any other liquid? Could alcohol or liquid methane have taken the place of water? The answer is no. The polarity of water, or the attraction of two poles, sets it apart from all other liquids. It has a positive charge at one end and a negative charge at the other, which allows it to dissolve almost any mineral or vitamin in itself. This quality of water makes it the best for transporting nutrients. In addition, the lower density of water in its icy state than in its liquid state is a blessing for aquatic life. When rivers or lakes freeze in winter, the ice layer remains on top, and fish and other organisms survive in the liquid water below. If water had started to freeze from the bottom, like a normal substance, all the water bodies on Earth would have turned into blocks of ice, and aquatic life would have become extinct. We have seen in our long discussion that water